Welcome to the tutorial for Lesson 9.2, Solving Systems of Linear Equations Using Elimination. By the end of this lesson, you will be able to write equivalent equations to eliminate a variable and solve systems of linear equations algebraically using the elimination method. There will be two parts to the video for this tutorial, and this is part 1. Recall that in Topic 8, we found the solutions to systems of linear equations by graphing the two equations on the same axis and finding the point of intersection of the lines, which was the solution. In section 9.1, we learned how to do the same thing, finding the solution of the linear system, but using algebra, and we used the method called the substitution method. Now we're going to look at a third method in this lesson for finding the solution of a system of linear equations. It is also an algebraic method, and it is called the elimination method. The elimination method is the second algebraic method that we are going to look at for finding the solution of a system of linear equations. In this method, we will be adding or subtracting the equations from each other to eliminate one variable, having one remaining variable to solve for. We will follow the following steps as we do the examples, but this is one place where they're all together, so you can always refer back to the steps if you need to while you're doing your practice questions. In example 1, we are going to solve this linear system of equations using the substitution method. So we got two equations here, and we have to somehow solve for a and b so that we get the values of a and b that make both equations true. So I have gone and rewritten the equations over where I'm going to be working with them so that the equations line up and like variables are in the same columns. So we have the a terms in the first column, the b terms in the second column, and the constants over on the other side of the equal sign, which makes up a third column. That's step 1. We need to have those so that the like terms are in the same column so that we can subtract or add the like terms. And why do we need to line up the columns? Well, if you were just adding or subtracting any two numbers, say, I'll just do this on the side, 524, let's go minus 312. Okay, and you need to line up the columns so that you have the ones in the first column, the tens in the second column, and the hundreds in the third column. And then you can go ahead and subtract those so that you're subtracting the right column numbers from each other. 4 minus 2 is 2, 2 minus 1 is 1, and 5 minus 3 is 2. So you get 212 is your answer. The same goes over here with our equations. Put an equal sign underneath them, and we will be able to add or subtract the like terms in the columns. Now we need to choose a variable in step 2 where they have the same or opposite coefficients. Well, if we look at the a values, the a has a coefficient of 4 in the first equation and a coefficient of 4 in the second equation. So because those coefficients are the same, we can just go ahead and go to step 3. So step 2 is just checking the coefficients. Step 3 is going to be to either add or subtract the equations so that we can eliminate the a variable. So what you do when you're in step 3 is you put the second equation in brackets, and then you decide whether you need to add or subtract. Now we're going to need to subtract these two equations, so we'll put a subtraction sign there, because 4a minus positive 4a is just going to equal 0a. And then 0 times any number, whatever a is still equal to 0, so it's actually eliminated now. Then we go ahead and we subtract the rest of the columns. 5b minus 3b is 2b, and then the equal sign just carries down, and 24 minus 12 is equal to 12. And because the a term is now equal to 0, we actually don't have to write it, so we can just pretend it's not there. And we have an expression now with just one variable in it. So that was step 3. Step 4 now, they're all kind of just right after the other. Step 4 is to solve for that remaining variable. So to get b by itself, it's being multiplied by 2, so we divide both sides of the equation by 2. That leaves b on the left side, and 12 divided by 2 is equal to 6 on the right side. So now we have one of our values. We know that b is equal to 6 in the solution for the system of equations. So now we need to go and find out what the other variable is equal to. What is a equal to? And this is step 5, and we can pick either of the equations from the very beginning, from the question. So we might as well just pick the first one. 4a plus 5b is equal to 24. Okay, and we know that b is equal to 6, so we're going to replace b with 6, sub it in there, so 5 times 6 equals 24, and then we start using our order of operations to solve for a. 5 times 6 is 30, so we do our multiplication first, and now we can just start isolating a by doing the opposite operations, so we'll subtract 30 from both sides first, and that gives us 4a equals negative 6. And lastly, we can divide both sides by 4. So you get a is equal to negative 3 over 2. And we'll just leave that as a fraction as our final answer. If you want to verify your answer, so this would be step 6, you can do that the same way we've always done that in the chapter 8 and in section 9.1. And you can sub in your values for a and b into both equations to make sure that it satisfies both equations. So if we take the first one, we have 4 times the value of a, which was negative 3 over 2, plus 5 times the value of b, which was 6, equals 24. And we want to make sure the left side equals the right side. So 4 times negative 3 over 2 would give us negative 12 over 2. Remember, multiply the tops together in a fraction and multiply the bottoms, and that's like saying 4 over 1. Plus 5 times 6, which is 30, equals 24. Negative 12 divided by 2 is negative 6, plus 30 equals 24. And negative 6 plus 30 is, in fact, equal to 24. So 24 equals 24, and it worked for the first equation. Let's check the second equation here. So we have 4 times negative 3 over 2 plus 3 times 6 for b equals 12. So the 4 times negative 3 over 2 is going to be the same as the above, so it just will equal negative 6. And 3 times 6 is 18, so plus 18 equals 12. And negative 6 plus 18 is actually equal to 12. So 12 equals 12. It works for both equations, so that is the verification. So our answer, or solution, is the point negative 3 over 2 comma 6 for this solution, or this system of equations. So in example 2, we have two linear equations again in a system, and we need to solve them using elimination. So we'll notice that our columns don't match up here. We don't have y's in the second column of both. So I'm going to take this first equation and I'm going to rearrange it to get the y and the 7 switched around. So I would have x plus 7 equals y. Now I want to move the y to this side, on the left side, and I want to move the 7 to the right side. So I'm going to have to subtract 7 from both sides. That gives me x equals y minus 7. And I'm going to have to subtract y from both sides, and that gives me x minus y equals negative 7. So this is the equation I want to use when I'm lining up my columns. So I'm going to come over to the left side here, and I'm going to write my two equations. X minus y equals negative 7 is the first one, and 2x plus y equals negative 8 is the second equation. Okay, so my step 1 is done. I've lined up my columns. Now I notice that my y's both have a coefficient of 1, however their signs are opposite. That's okay. We need the same or opposite numbers in front of our variable. Negative 1 and positive 1, they are opposites. So we can go ahead and just decide if we need to add or subtract these equations. So step 3, we need to put the second equation in brackets, and we need to decide, so negative 1y plus or minus y equals 0y. And that is going to be adding. So we're going to put a plus sign out front. Now, 1x, there's a 1 there, 1x plus 2x's gives you 3x. Negative 1y plus a positive y is equal to just 0 y's, so we leave that as 0 or as nothing there. And negative 7 here plus negative 8 would give us negative 15. Please be careful when you're adding and subtracting integers that you use the right signs. Okay, so now what we need to do is we need to solve for x, the remaining variable. So this would be step 4. Divide both sides of the equation by 3, and you get that x is equal to negative 5. So let's go now and solve for the y variable, knowing that x is equal to negative 5. So we go back and we use one of our equations from the very start. I'm going to choose the first one, x plus 7 is equal to y. You can use either one. They will still give you the same answer. Now, x is negative 5, so I'm going to sub negative 5 in for x, and negative 5 plus 7 is equal to 2. So y is equal to 2. Therefore, our solution is going to be the point negative 5 comma positive 2. And you can go ahead and check that by subbing negative 5 in for x in your original two equations in the question, and subbing in 2 for the y's, and then making sure that the left side of the equations equals the right side of the equations. All right, a quick reminder about fractions. If you see fractions in the equations, you can first multiply the entire equation by the lowest common multiple of the denominators to get rid of the denominators. So in this example, our denominators are 2 and 3, and the lowest common multiple between those two is 6. So we multiply the whole equation by 6. That gives us 6 times 1/2 x plus 6 times 1/3 y equals 6 times 5. You have to multiply every term by that number. Well, 6 times 1/2 is just equal to 3x, and 6 times 1/3 is equal to 2, so we have 2y, and that's equal to 6 times 5, which is 30. And then you can go ahead and use this equation to do what you need to do when you're solving.